Hi everyone, you're watching a video in the motion series of VCE Physics, and we're going to look at projectile motion specifically in this video. Now the first projectile motion video I did involved a cannonball being shot directly horizontally off a cliff. And I promised to do this video because in this video we're going to be showing how to solve questions where an object is launched from the ground, pictured here, at an angle, and then the path of the object is parabolic as it rises and falls back to Earth like so. I'm going to set up the question first, and then we're going to solve for about 7 wanted values, which I'll list down. So first of all, assume there is some kind of explosion that occurs over here, and a bit of debris is launched into the air. It doesn't matter how heavy it is, but we'll say it's launched at an angle of 60 degrees to the horizontal at a velocity, a speed of 90 meters per second. That is all the information we're going to be given. We don't need to know the weight of the object because gravity accelerates all objects downward, at least in VCE physics, at the surface of the Earth at around 10 meters per second squared. That is what is going to determine the motion of that projectile. So it's a bit of debris. Now the values we want to find, I'll list them on the left here. 1, the initial vertical velocity. 2, the initial horizontal velocity. 3, the max height. 4, the time taken to reach max height. 5, the total time of flight. 6, the range, so the horizontal distance to the point of impact over here. And then 7, if there's a 2 meter tall man 675 meters out, we're going to figure out if this bit of debris does indeed hit him. So there's a man standing somewhere there, and we're hoping the debris doesn't pass through those 2 meters. So first of all, the vertical velocity. Velocity is a vector, so even though we've been given the speed at 90 meters per second in that direction, we can actually describe the bit of debris as having velocity horizontally as well as vertically. So the vertical velocity is going to be given by the size of that purple arrow there, and that is sine 60 degrees times 90, which is around about 78 meters per second. So if we were to just ignore the fact the object is traveling to the side, as it leaves that explosion, it is traveling with an upwards direction at least of 78 meters per second. So after a second, if there were no other forces acting on it, it would be 78 meters higher in the air. But also, since it does have horizontal velocity, it would be a long way to the right there. So the vertical velocity we've found, 78 meters per second. The horizontal velocity is the size of that purple arrow there, and that's given by cos 60 degrees times 90, which is equal to 1/2 times 90, or 45 meters per second. This is a very useful value because gravity acts directly down on the bit of debris the entire time it's traveling through the air. Gravity will only change the vertical velocity. The horizontal velocity, provided there's no air resistance, is going to be 45 meters per second for its entire trip. So after 1 second, it'll be 45 meters away from the explosion. After 2 seconds, it'll be 90. And after 3 seconds, 135 meters away, horizontally at least. but of course it'll be above those points in the air somewhere. The third value we want, the max height. This is when we start using our motion equations. So we know vertically, so we're just thinking vertically now. I'll write that over here. Vertically. We know u, initial velocity, is equal to 78. We know the acceleration is -10 because the acceleration is in the opposite direction to the initial velocity. We know its max height, the vertical velocity will be 0, but we don't know the time taken or the displacement. The max height is the vertical displacement when the final vertical velocity is 0. So we use one of our equations that has v, a, u and s in it, v, a, u and s, and we say v squared is equal to u squared plus 2as, v squared take u squared all over 2a is equal to s, which is equal to 0, take away 78 squared all over 2 over -10, which comes to a total of -78 squared is -6084 divided by -20. That comes to 304.2 meters. So the max height is equal to 304.2 meters. That is how high the debris rises above the ground, say at that point there. So that height is around 304.2 meters. I'll just say 304 since we have made some approximations already. I don't want to be presumptuous about how accurate these answers are. The time to reach that max height is a little easier to find. We know u, we know a, we know v, but we don't know t. Which of these formulas has those three knowns? V, u, a, don't know t, we can use this top one. So v is equal to u plus at, v take u on a equals t, v take u would be 0, take away 78 over -10, which is equal to 7.8 seconds. So at the point where the debris passes that point there, time equals 7.8 seconds. Time to reach the max height, 7.8. The time to complete the entire flight, well, that's just double of the time it took to come up, because on the way up the object behaves very similarly to how it does on the way down. So the total time of the flight is equal to 2 times 7.8, which is 15.6 seconds. Now we can find the range. I said gravity only affects the vertical velocity. The horizontal velocity does not change. So this 45 meters per second, the velocity at which the object is moving that way, will enable us to find the range. If the object is indeed in the air for 15.6 seconds, then the range is equal to the distance sidewards, which is equal to velocity times sideways velocity times time, which is equal to 45 times 15.6, which comes to 702 meters. So it has a max height of 304 meters and a max range, so a horizontal distance to the point of impact, of 702 meters. Now the final question, a man standing at 675 meters, that's 702. So a man standing at 675 meters, somewhere here, with a height of 2 meters. So we don't know how big that is exactly, since this drawing, we don't know if the shape is right or the scale is right. Most certainly, there's not a good scale going on here. So there's a man standing there. We want to know if this man is struck by the projectile. So does the projectile pass through that green line there? By the time the projectile, we want to find the time it takes for the projectile to cover 675 meters that way. And that's easy because the horizontal position of the object is given by 45 times time. So 675 is equal to 45t. 675 divided by 45 comes to 15. So after 15 seconds, the object is at least in line with where the man is standing. As to how high above the ground it is, we still don't know. For that, we're going to have to use one of our motion formulae. We know t, we know a, we know u, but we don't know s. So we'll use this formula here. So this is the last thing we're going to work out. Whoops. Shrink all this down and move it over here. S, so the height above the ground of this object, is given by ut. Vertically, that's 78 times 15, t being 15, plus a half, a is negative 10, times 15 squared. And that comes to plus 0.5 times negative times 15 squared, 45 meters in height. So at 15 seconds, the object is 675 meters to the right and 45 meters in the air. Now the man is only 2 meters tall, so it's pretty clear that it's going to go way over his head.